Zalalam from 2620 is active. Today we will discuss about logical operators and exercise in NetBeans IDE. If you are new to my channel, please subscribe, and if you like the video, comment, share. So we have got various logical operators in Java, and first one is logical AND, which is denoted by ampersand, and the short circuit form is denoted by double ampersand sign. And when we say short circuit form, this operator will evaluate its first operand, and if it is false, it will stop evaluating the second argument or operand and continue to the next statement as the output will be false. But if the first operand is true, it will evaluate the second one and produce the output. The logical OR is the other operator, which is denoted by the vertical bar, and its short circuit form is denoted by double vertical bar, and the short circuit form evaluates the first operand, and if the first operand is false, it will evaluate the second one, but if it's true, it will ignore the second one and produce the output of true, as whether the second operand is true or false, the output will be true. The third logical operator is exclusive OR, logical exclusive OR, denoted by the upward inverted greater than sign. And the other logical operator is NOT operator, logical NOT, which inverts the operand. If it's given false, it will produce true. If it's given true, it will produce false. The other operand is equal to sign, which is denoted by double equal sign, and it's sometimes called equality operator. And the previous four operators have got augmented form, whereby their symbols is followed by one single equal sign, and this results in evaluating the two operands with the logical operator and or exclusive or not, and assigns the output to the left operand. Okay, so we will see the exercises in our IDE and it will be clear there. So we are in our IDE to exercise on logical operators. Let's declare some variables. A, so once we have our variable, let's see how we use the logical operands and get our output. So if I declare another variable, as we have discussed, so as we have discussed previously, the output of logical operators is a Boolean value. So if I print out the output variable, I'll get the result of evaluating A and B. So we can see the we can see this one. So we expect a false value, and if we reassign output to be equal to A and C and print out the output, okay, we will see another value. Now here A is false, B is false. We expect the output to be false. Now here A is false and C is true, so the output will be false because both have to be true to be the output true. If we use the short circuit form, it will be like A and C. So you cannot observe the difference between the two, but this one evaluate A, and since A is false, it will stop evaluating the second one and assign a value of false to output. Okay, so if we C and D, we will get output of evaluating true and true, which will be true. So let's run this one and see the three outputs. Okay, so false and false is false, false and true is false, true and true is true. Likewise, we can see the output of evaluating logical OR. Let's say okay, so here A or B, since they are both false, we expect a false output, and C and D, A and C, false and true, we expect a true output. These both are true and we expect a true output. So let's comment out these ones with a multi-line comment, and okay, now we have assigned output here and we have reassigned it here. So if we run this one, we expect a false true result. Let's run this one and see the output. Okay, so the OR has got a short circuit form and it's written like this, and this one is false, it will evaluate this one. Let's make on the double bar sign, and it will evaluate C, and when it is true, the output of true will be assigned to output, and evaluation of A will be ignored if we use the short circuit form, which is double vertical symbol. Okay, the other operator that we have got is the logical exclusive OR. Okay, so let's reassign output to be A or B, X or B rather. So these both are false, so we expect a false value, and okay, but if we A or C, we expect the output to be true, as one of them is true. And if we do C and D, we expect a false output as both are true. As we have discussed, either of the two should be true to make a true output. If both are false or both are true, we expect a false output. Okay, so both are false to be false. A, X or C, A is false, C is true, so that is true. C, X or D is false because both are true. We have got another logical operator called not. So to assign output with a node, we can say node A. Okay, so this is a valid statement, and this will assign the value of the inverse of A to output. Okay, so if we print out output, we will get true. Okay, and if we assign output with not C, we expect a false output since C is true. Okay, let's run this one and see. So not A is true, not C is false. Okay, the other is the equality operator. Equality operator is an evaluation operator, so we can look into the implementation of equality operator as, for example, A is equals to B. Okay, so since both are false, the output of this will be true. Let's continue with our similar previous example and assign output to okay, so we can print output here. So this is going to be false is equals to false, and this is true. The output will be true. And if we assign output to A is equals to C and print out output, we will get a value of false because A is false and C is true, and false is not equal to true, so the output will be false. Let's include in the comment the previous examples so that we can have a quick output. So A is equals to B is false and false true, and A is equals to C is false because A is false and C is true. The other logical operators, rather than other logical operators, the augmented operators are used as, for example, let's say we have assigned A to be false, and if we AND equals to B, we will assign the evaluation of A and B to the value of A. So to make it clear what will happen, let's assign the value of C to the value of B. Since C is, we have declared it to be true here, we expect the output now of C to be false. Okay, so if we run this one, we will get the value of C to be false, as we have ended it with B and assigned the output to itself. Okay, so now C is false. Likewise, we can do OR augmented for with a single bar, equal sign, and D. So A or D assigned back to A will be will make A true. Okay. So if we run this one, we will get the value of A to be true. So the upper one is the value of C, this one is the value of A. Okay. Same is true with exclusive OR. We can exclusive OR with D and assign it back to A, and this will result in A to be true. Let's make it B and print out the result. Since B was false boolean, we expect it now to be true. Okay, so we get the value of B to be true here too. The other the other logical operator is not equal to, and so we have to assign output to be equals to A, not equals to C. So here, not equal to C, A is now true and C is now false, so the output will be true since both are not equal. So for one last time, if you compile this one, we will get the last output to be true, as A is true and C is false, and the value of output will be true. This is to show you how to use logical operators, but logical operators are very important in conditional statements, so we will discuss their use in the section on control statements, but for now this is what I have for you. Thank you for your time.